So dear student, now we are going to discuss question number 2.23, and in this question it is given to you, an electrical technician requires a capacitance of 2 microfarad in a circuit across a potential difference of 1 kilovolt. Okay, a large number of 1 microfarad capacitor are available to him, and each of which can withstand a potential difference of not more than 400 volt. Okay. Now we have to suggest a possible arrangement that requires the minimum number of capacitors. Clear? So now let us try to understand the given situation. Let's suppose it is given in this question that each capacitor that is available of 1 microfarad. Clear? And now we have to make a circuit in which we will find equivalent capacitance. This is 2 microfarad. Clear? So let's suppose I am drawing here, let's suppose this is 1 capacitor, let's suppose this is 2 capacitor, let's suppose this is 3 capacitor, and let's suppose total we have n capacitor in this circuit. Clear to you? Now, so we can see if we are connecting n capacitor in a series, and let's suppose this is connected with a battery, it is connected with the battery, and potential difference is given to you, this is 1000 volt. Clear to you? This is 1 kilovolt. Clear? Okay. So now we can say here we are having capacitor, let's suppose C, this is also C, this is also C. Clear? So my dear student, when n capacitors are connected in a series, how can we find equivalent capacitance? So we can write like this, 1 upon C dash, this is given by 1 by C plus 1 by C plus 1 by C and so on up to n times, because we have total n capacitor. Clear? So we can say this is n times. Clear? So from here you can write like this, 1 by C dash, it is equal to n by C. Clear? So we can say C dash value, this is given by C by n. Clear? Now we can say here we have equivalent capacitance, this is C by n. Yes or no? Now let's suppose if I am saying to you, let's suppose here we have total m number of rows, such that we have total m rows. Clear? Yes or no? So if we are talking about n number of rows, then what is equivalent capacitance? Now we can say for one row of this capacitor, we can say we have equivalent capacitance C by n. Now we can say like this, we have total m capacitors are connected in a parallel. So we can see equivalent capacitor in parallel combination, this is given by C equal to C1 plus C2 plus C3 and so on. So from here we can say C double dash, this is given by, we can say m times of C by n. Yes or no? Because we have total m number of rows, we can write like this, m times of C by n. Clear? Now one important information is given to you, value of one capacitor, this is 1 microfarad. Clear? So I am writing here m by n, this should be equal to value of C is 1 and value of C double dash, this is given to you, this is required 2 microfarad. Clear? So you can write like this, m by n into 10 to the power minus 6, this should be equal to 10 to the power minus 6 multiplied with 2. Clear? So from here we can say this one and this one cancelled out. Clear? So value of m, this should be equal to twice of n. Clear everyone? So let's suppose this is equation number 1. Clear? Now, now listen carefully. Now we can say when n number of capacitor in a row is connected in a series and it is connected with 1000 volt battery. So this potential is actually equally distributed in each capacitor, because in series combination we have total charge in a capacitor, this remains same, but potential is divided. Clear to you? So from here we can also write like this, we can also write like this, we have value of potential, we can say we can write potential of each capacitor, this is given by 1000 volt divided by total, we can say 1000 by, we can say value of potential, or we can say number of capacitor. Yes or no? Clear what I am saying to you? Actually here we have, let's suppose we have here 1000 volt battery. Let's suppose we are connecting here 10 capacitors. In series combination we have charges same, so but potential is divided. So we can say each capacitor is having 100 volt, 100, 100, 100, 100. So total 10, we can say this is 1000 volt. Clear to you? So we can say here this is equal to, in this question it is given a capacitor that can withstand up to a maximum of 400 volt potential difference. So this should be equal to 400. Clear to you? Yes. So from here we can say value of N, this is given by 1000 upon 400. Clear? So from here you can say this one is cancelled out. From here this is 5 by 2 and this is 2.5. Now we can say we are getting from calculation total number of capacitor in a row. This is 2.5. Now we know half capacitor does not exist. So we will take it, this is equal to 3. Yes or no? So we can say total number of capacitor in a row, we have total 3. Clear? So now can we calculate value of total number of rows we have? Yes, we have one relation M equal to twice N. So we can write like this, M, this is equal to 2 and multiplied with 3. Clear? So from here we can see M, this should be equal to 6. Clear? So from here you can see that we have total 3 capacitor in one row, and such capacitor series we have total 6 number of rows. Clear? So now can we make here a possible arrangement in which we find equivalent capacitance 2 microfarad? Yes or no? And each capacitor can hold maximum of potential difference 400 volt. Clear? So now we are going to draw that arrangement. Clear? So actual arrangement we can draw like this. This is one capacitor, another capacitor, another capacitor. Clear? This is one row. We need here total 6 row. 1, 2, 3, this one, 2 row, 1, 2, 3, this one. Clear? 1, 2, 3, 4. We can also do like this, 1, 2, 3, this one. Clear? We need one more row, 1, 2, 3, this one, and finally it is connected with the battery that is having potential difference 1 kilovolt. Clear to you? Now we can say each capacitor is having value, this is 1 microfarad. So you can say value of each capacitor here we have C equal to 1 microfarad. Clear to everyone? So now we can say this is the possible arrangement that is required for the electrician. Clear? So this is all about this question. Clear to everyone?